So we'll see the next concept. So questions related to population increase or decrease, and also questions related to depreciation concepts. Say they ask questions in this populations also. Say suppose population of a certain certain place is 50,000, and if every year it is increasing by 10%. So what is 10% of 50,000? So it is 5,000. So if it increases by 10%, so the next year population will be not 50,000, so it will be 55,000. And in this 55,000, there will be an increase of 10%. So it will not be the same 5,000. So we have to find 10% of 55,000. So it will be 5,500. So the increase will be now 5,500. So as population increase is a biological process, so we have to find the population after a certain number of years, which is given in the question. So this working is similar to the compound interest questions, where on the increased value we calculate the increase, that is where we have interest on interest. So we'll see how to work out this type of questions, and we'll understand this concept with a few examples. So we'll see the examples now. So we'll see the first example, and the question is, population of a city increases at the rate of 5% per annum. So if the population of the city is 1 lakh, then what will be the population of the city after 3 years? So rounded off to the nearest number. So here the initial population value is 1 lakh. So it is increased by 5%, and every year it is increasing by 5%. So the change factor will be, as it is increased, so 5 is added with 100. So change factor will be 105 by 100, and this is multiplied thrice because the population is asked after 3 years. So we'll see the answer for this question. So every year population is increased by 5%. So whenever increase is given, so the change factor will be, it is 100 plus 5 by 100. So every year it is increasing by 5%. So change factor will be 100 plus 5 by 100. And now what is the initial population given? The initial population is 1 lakh. So in this 1 lakh, so it is increased by 5%. So the change factor will be 100 plus 5, 105 by 100. So the next year, so in this increase, we will have a 5% increase. And it is for the third year also the same. So multiplying this all and dividing, we get the population of the place, of the city after 3 years. So here as the percentage is same, so every year percentage increase is same. So we can work out using this compound interest concepts also. So how to find the amount when the initial value, when the principal is given? So the same concept we can work out. So amount will be the value of the population, the number of population after 3 years, and initial value is 1 lakh, and change factor is 105 by 100, the whole cube. So 1 plus, so it is 1 plus r by 100 whole power n. So as change factor is 5. So it is 100 plus 5, 105 by 100, the whole cube. So we have here 100 multiplied thrice and 105 cube, and cancelling all the zeros, we have 105 the whole cube by 10. So now cube of 105 is found, and dividing it with 10 we get the population after 3 years. So we can find easily cube of a number where you have 0 in the middle. So all this concept we have seen in this speed math, and I'll tell you how to find cube of this 105. So using the concept expansion of a plus b the whole cube, here we'll consider a as 1 and b as 5 and expand. So it is a cube plus 3a square b, 3ab square and b cube. And as taking a as 1, so the expansion will be 5 cube, 3 into 5 square, 3 into 5 1 cube is 1. So what is 5 cube? It is 125. And what is 5 square into 3? 25 into 3, 75. So 5 into 3 it is 15 and 1. And now as this is of base 100, we can have 2 digits in each term. So answer will be 25. So adding this 1 with 75 is 76, 15 and 1. So cube of 105 is 115, 7625. So this is 115, 7625. So divided by 10. So now what will be the population after 3 years? It is 11576, 2.5. So as we can't have a decimal for population, so the rounded off number according to the option, it is 115763. The population after 3 years, where initial population 1 lakh is given and it is increasing by 5% every year. So after 3 years it is 1,15,763 and the answer is option B. So we'll see another example. So where we work out on the concepts of depreciation. So whenever we get questions based on population increase or amount deposited in a bank, so every year the value is appreciated. So we use the change factor where it is added with 100 and multiplied. Suppose we buy a machinery or a vehicle, so every year because of this wear and tear, the value decreases. So this is called as depreciation. The wear and tear of a machine or a vehicle, after a certain period, it decreases and this is called depreciation, and the certain depreciation rate will be given. So as we found for the increased factor, so we can find the depreciation factor also, value also, after a certain period for the given percentage. Say suppose we buy a vehicle for 1 lakh. So if depreciation rate is 10%, so what is 10% of 1 lakh? It is 10,000. So after 1 year, value will be 10,000 less than 1 lakh. So it will become 90,000. And next year, so it is 10% of 90,000. So what is 10% of 90,000? It is 9,000. And value becomes, in the second year, 81,000. And so on. So every year, based on the present value, the rate is calculated. And 10% of 81,000 is 8,100. And subtracting, so every year we can find the depreciating rate. So based on this concept, we'll see an example. So here, the question is, a car was purchased for a price of rupees 4 lakhs. So it was depreciated by 30% in the first year and by 10% in the second year. So what is the depreciated value of the car at the end of the second year? So it was bought for 4 lakhs and every year the value of the car, so because of this wear and tear, depreciation occurs and the depreciation rate is given here. So the first year depreciation rate is 30% of the initial value. The second year depreciation is 10%, rate of depreciation is 10% and this 10% is in the decreased value of the first year. So we'll see what will be the depreciated value at the end of the second year. So we'll see the working. So whenever the value is depreciated, it means that it is less than 100. So whatever the percent is given as the depreciating rate, we'll subtract it with 100. So the initial value is 4 lakhs. And what is the depreciating rate for the first year? So it is 30%. So in this 4 lakhs, 30% less. That is 100 minus 30 by 100. So in this 70% of this 4 lakh, in the second year, depreciating rate given is 10%. So whenever we are finding the depreciating rate, so in this 70%, it is 10% decrease. So don't subtract 10 from 70. So mostly many of them do this. So it should be always from 100, we should subtract the decreasing factor or add with 100 the increasing factor. So the next year it is 10%. The value of the car is asked after 2 years. So now what will be the value after the depreciation of 30% first year and 10% the second year? So it is 4 lakhs. So 100 minus 30, it is 70 by 100. And now simplifying, we get the answer. Or so what is product of 7 and 9? It ends with 3 and multiplied with 4, it will end with 2. So we can choose the option which has the number, the first number as 2. So when we check the options in option B, we have the first number as 2. So 2,52,000. So that will be the answer. So you can guess the answer from the options with the unit place itself or by multiplying. So just give a glance at the options, and mostly with the help of the options you can get the answer. So instead of multiplying and working out, so working with the unit place itself, so we can guess what will be the answer, and we have only one option which ends with 2. So option B will be the answer, or the product will be 4,000 into so which is equal to 60. So the value of the car after 2 years, after the depreciation of 30% first year and 10% second year is 2,52,000. So answer is option B. So we'll see another example for this appreciation and depreciation concept. So we'll see the next example. So the question is, a person purchased a land for rupees 2,89,000 and constructed a house upon the land by spending rupees 5,29,000. The land value is appreciating at the rate of 15% and the building value is depreciating at the rate of 15% every year. After how many years the value of both the land and the building will become equal? So here we have a question where both the concepts are there. So appreciating concept and the depreciating concept. The person buys a land and land value every year it appreciates by 15%. The land value is 2,89,000 and he builds a house of worth 5,29,000 and this house value every year it depreciates by the same 15%. So after how many years both will become equal? So we'll see the working. So now value of the land appreciates. So initial value of the land is 2,89,000 and as the value is appreciating by 15%, it is 100 by 100 plus 15 by 100 whole power n. And we are asked to find after how many years both the values will become equal. So this value of the land appreciating 15% every year, after how many years will be equal to the value of the house, so which was built at the worth of 5,29,000 and it is depreciating 15% every year. So as it is depreciating, it is 100 minus 15 to the power of n. So we have to find the number of years where both the amounts, both the values will become same. So here value increases and here value decreases, then both the values will become same. And now the working will be, so 100 plus 15, it is 115 by 100, the whole power n. So 100 minus 15 is 85 by 100, whole power n. I am bringing this change factor to one side, so that is 115 by 100 whole power n, and dividing by 85 by 100 whole power n. So this is equal to 5,29,000 by 2,89,000. So cancelling out the common factors. So here we have, so this division is reciprocated and multiplied. So as we have the common part, so it is equated. So common part is n. So which is equal to 529 by 289. So cancelling this 100. So we have 115 by 85, the whole power n. So here we have the common factor 5. So simplifying it is 23 by 17, the power n. So 23 and 17 both are prime number and it can't be simplified yet. So here on the right hand side, it should be power of this fraction. So now when you check here, we have 529 is square of 23, 289 is square of 17. So this can be written as, so 23 by 17 the whole square. So now after how many years, both the worth of the land and the house will become same. So cancelling the base, n equal to 2. So after 2 years, both the values will be same. And now here, so value of the land which appreciates every year by 15% and value of the house which depreciates 15% every year. So it will be same, the value will be same after 2 years. And now for this question, so instead of doing all this, so with the values of this house and the land itself, so we can decide what will be the number of years. So instead of doing all these workings, so we have here, so we'll divide this value of the house by value of the land. So it is 2,89,000. And you check what will be the common power of this fraction. So 529 is square of 23, 289 is square of 17. And you can write this as 23 by 17 the whole square. So number of years will be 2. So because common power is 2, so it should be after 2 years the value will be same. So after getting this, we can cross check whether we get the same fraction on the left hand side. So now with the values itself, so choosing the common part which the numerator and the denominator can have will give you the number of years. So it is after 2 years, both the values will be same. Say for example, another example. So if house value is, so 13 lakhs and 31,000 and land value is 7 lakh and 29,000. So now what will be the common power for both these values? So it is cube of 11. So this is cube of 9. Now seeing this value, we can decide what will be the number of years. So after how many years both the values will be same? So it will be for 3 years. So because 11 cube, so after cancelling this, 11 cube is 1331 and 9 cube is 729. So this will be the increase of 10%. So this will be the decrease of 10%. So 100 plus 10 is 110. 100 minus 10 is 90. So when you simplify, 11 by 9 cube is 1331 by 729. So with the values itself, we can decide the number of years. So for this value, number of years will be 3, where the values will be same.